This is lecture 15 and is a continuation of our discussion of feedback amplifiers from lecture 14. In lecture 14, we introduced the basic concepts of feedback amplifiers, their structure, their properties, underlying operation mechanism, how the negative feedback improves the performance of the amplifier. And in this lecture, we'll discuss about the different types of the feedback amplifiers, or commonly they are known as the feedback topologies. What are the different feedback topologies? What are their structure, how they work, and what are their features? So this lecture is divided into two segments. In the first segment, we will introduce to the basic structure of different feedback topologies and their working mechanism, and we'll see in more detail the different features of these feedback topologies in part 2 of this lecture. So now we'll discuss about the feedback topologies. What are the different types of feedback that we can have in an amplifier? In the feedback amplifier, it samples the signal at the output and mixes the signal at the input. Now the signal can be either a current or a voltage. Now depending on the signal type, whether it is sampling a current or voltage at the output, and the signal type at the input side, whether it is mixing a current or a voltage, we can have four different feedback topologies, because there are two variables at the input, current and voltage, and two variables at the output side, current and voltage, and we can have four different combinations of these signals. And with these four different configurations, we have four different feedback topologies. The first one, we can say the sampling the voltage at the output and also mixing voltage at the input side. The sampling voltage sampling, voltage mixing feedback amplifier. So both at the input and output signal is in the form of voltage, and next the voltage sampling, current mixing. So at the output is sampling the voltage, but at the input side it is the signal is in the form of current and mixing current at the input side. So that is another feedback topology. Then we can have sampling current at the output and also mixing current at the input. So signals both at the output and at the input side are in the form of current. So that is another feedback topology. And the last one, we're sampling current at the output but mixing voltage at the input side. So signal is in the form of current at the output and it is in the form of voltage at the input. So these are the four feedback topologies that we can have in a negative feedback amplifier. So now we will see in some detail how we represent the different feedback topologies in a block diagram. This is the block diagram that shows the basic structure of voltage sampling, voltage mixing feedback topology. So as usual, we have the basic units for the feedback amplifier, the basic amplifier, and the feedback network. Now it is sampling voltage at the output. So you see the connection here, that is sampling the output voltage and that is applied to the input of the feedback network. The feedback network is producing a proportional voltage which we call the feedback voltage denoted by Vf, and see the connection at the input side, and also the polarity of Vf with positive on this side, negative on this side, so that the Vf is subtracted from the source voltage Vs, and the difference is applied to the input of the basic amplifier. The difference signal here is Vi, difference between Vs and Vf. So this is how the voltage sampling, voltage mixing feedback amplifier will work. And as you can see, the connection, the type of connection that we have at the output, because it is sampling the output voltage, the connection is, we call it shunt connection or parallel connection. And then the feedback network, the voltage that is producing at the output side, that is mixed with the signal voltage in a way so that it is subtracted. And for that, this voltage here Vf is put in series with the Vs. Don't put in parallel, because that way, don't get the difference, get the same voltage. So these 2 volts, they are put in series. However, the connection at the output side is in shunt connection. So the sampling voltage at the output side, it is done by applying the shunt connection, and the mixing the voltage at the input side is achieved by having this series connection at the input side. So this type of feedback is also known as the series shunt feedback topology. As you can see here, this indicates to the type of connection that feedback topology will have. The first term series indicates the connection at the input side, and second term shunt indicates the connection type at the output side. So the voltage sampling, voltage mixing feedback topology is also known as the series shunt feedback topology. In this case, the gain of the basic amplifier is V0 by Vi, is a voltage gain. Both the signal both at the output and at the input side are in the form of voltage. So the gain of the basic amplifier is a voltage gain, and the type of the amplifier will be also a voltage amplifier, because it is amplifying a voltage signal. Our next feedback topology is voltage sampling current mixing feedback topology. So the block diagram here shows this feedback topology, where it is sampling the voltage at the output side, and it has the same shunt connection, and it is mixing current at the input side. So the feedback network is producing a proportional current IF at the output, and that will be mixed with the source current IS. Now you see the direction of the IF is such that this IF will be subtracted from IS, and the difference will go in the basic amplifier, which will then amplify this current. So the connection, if we see that output side, the connection is shunt connection because sampling the voltage, and while at the input side it is also shunt connection because it is mixing the current. So at this node the two currents are mixed, and the difference goes into the basic amplifier. So what we have both at the input and at the output side, this feedback topology has a shunt connection, and this we also call shunt feedback topology. Now the gain of the basic amplifier, if you see that the signal at the output side is in the form of voltage, while that at the input side is in the form of current. So the gain of the basic amplifier we can write as V0 by II. Now voltage by current is basically is a resistance. So this gain is also known as the transresistance gain. Trans stands for transferred, the resistance that is transferred from the input side to the output side. II is the input current, V naught is the output voltage. So it's kind of resistance that is transferred from the input to the output side called transresistance gain, and the amplifier type is known as the transresistance amplifier. Our next feedback topology is sampling current, current sampling, and current mixing. Now this is the block diagram, and you see how the circuit is connected at the output so that the output current can flow through the feedback network. It's a kind of series connection to allow the current to output current of the basic amplifier to flow into the feedback network. The feedback network is producing another proportional current, the feedback current at its output, and then this output current will be mixed with the source current like before. So the current, since we are mixing at the input side, the connection remains same as the previous one. It is a shunt connection, and the at the output side, this is a series connection to allow the current output current to flow into the feedback network. So the connection, the type at the input side is shunt, at the output side it is series, and it is also referred to as shunt series feedback topology. Now the gain of the basic amplifier in this case, since both at the input and at the output side signal is in the form of current, so gain of the basic amplifier given by I0 by II, this is the current gain, and the amplifier type is a current amplifier. It is amplifying current and producing a proportional current at the output. This is our last feedback topology. The current sampling and voltage mixing. It is sampling current at the output side like in the previous case. So the connection at the output side remains same. It's a kind of series connection where the output current from the basic amplifier will flow into the feedback network. The feedback network in this case is producing a proportional feedback voltage at its output, denoted by Vf, because at the input side we are mixing voltage. So Vf here is mixed with the signal voltage in a way that it is subtracted, and the difference goes into the input of the basic amplifier. So the connection at the output side, while it is series connection, at the input side is also series connection. So here both at the input and the output side the connection type is series, and this feedback topology is also referred to as series feedback topology. The gain of the basic amplifier in this case, since the output is in the form of current and the input is in the form of voltage, the gain of the basic amplifier will be given as I naught, the output current divided by Vi, the input voltage. And current by voltage, we call it conductance. And in this case, it will be transconductance, conductance that is transferred from the input to the output side. And the amplifier type, we call it transconductance amplifier. So this is how we have four different feedback topologies: the voltage sampling, voltage mixing, voltage sampling, current sampling, current mixing, and current sampling, voltage mixing. And for feedback topologies, we have four amplifier types: the voltage amplifier, the transresistance amplifier, the current amplifier, and the transconductance amplifier.